Alright, we're going to work on problem 10.1. You can read it here. There's part A, part B, and part C. Let's start. So part A asks us to find the work input to the compressor. In order to find that, it would be easier to draw a Carnot cycle, which looks kind of like this. This is here. This is for our condenser. This is our evaporator. So we know, or in our substance is refrigerant 22. So 1, 2, 4, 3. So since our H2 is on the saturated vapor line, we get that H2 is equal to Hg. And since we are given our temperature at that point, we have there our H2 equals 259.32 kilojoules per kilogram, and that our S2 is equal to 4 times K. And again, this is evaluated at 32 degrees Celsius. That is a given temperature. And it is this pressure right here. So, knowing that S1 is equal to S2 and S3 is equal to S4, that will facilitate our problem a lot. Also knowing that T4 is equal to T1 and T3 is equal to T2. Alright, so now we can evaluate our values at state 1. So at T1 equals 0 degrees Celsius, we find, and again that is on the tables for refrigerant 22, we find our SF values, which is 0.1773, SG, HF, and HFG. Since we don't know the location of our point at state 1, we need to find our quality, knowing that S2 is equal to S1. That is 24. So we're going to use this equation. So we plug in these values, plug it here. Our S2 we already know to be 0.8842. We plug this here, minus this. So after solving for x1, we get that our quality at state 1, is going to be 0.9428. Simple enough. After finding our quality, now we can find our H1 using the same process. So we plug in the values that we found in our value of our quality, which we just found. So this is just HF X1. That's the formula. We find the H1 is equal to 238.21 kilojoules per kilogram. Now, we know that T2 equals T3, so T3 also has to equal 32 degrees Celsius, and that is sat liquid is equal to HF, which is going to be equal to 84.14 according to the tables, and our SF is going to 0.3101 kilojoules per kilogram times Kelvin. Knowing this, we know that our S3 is equal to S4. So we're going to do that the same process we did for state 1 to find our values for state 4, which is going to be using our quality. So we're going to find our quality using this equation again. S3 is equal to SF plus X4 SFG. We plug in our values and we find that our X4 is equal to 71. So again, we find our values for H4. We plug in our values. 1771, 204.81. Again, this is our HF. This is our quality that we just found. This is HFG. We finally found that H4 is equal to 81.39 kilojoules per kilogram. Now we are ready to find the answer for part A, which is going to be to find the work of the compressor. But before we have to do that, we also have to find our coefficient of performance, which is equal to beta. And that equals our temperature cold over temperature hot minus temperature cold, which we already found to be, and then this we have to convert our values to Kelvin. And this equals to our 0 degrees, and this equals to our 32 degrees Celsius. So after doing that calculation, we find that our coefficient of performance is 8.53. Now we're going to find our work at a compressor, and that is going to be equal to H2 minus H1. And since we already know those values, we just plug them in. Kilojoules per kilogram. We find that our work compressor is going to be equal to 21.11 kilojoules per kilogram. Alright, now part B asks for the work of the turbine, and that is going to be equal to H3 minus H4. Also, we already know the values, so we plug them in. 84.14 minus 81.39, and that is all in kilojoules per kilogram. We find that our work at our turbine is equal to 2.75 kilojoules per kilogram. Simple enough now that we found all our values. And then to finish off, we have part C, which asks for our heat addition, which is our Qn, which is in this process H1 minus H4. So we plug in our values again. 8 minus 81.39, again all in kilojoules per kilogram, and we find that our Qn equals 156.82 kilojoules per kilogram. And that is it for problem 10.2.